Recently, I saw a patient with a duplicated gallbladder, and it was the only time I've seen a duplicated gallbladder in my career, and also my colleagues had never seen it before. So I thought this was interesting. And I said to myself, what could this mean? A duplicated gallbladder? Was this just genetic variation by chance, or perhaps is there something more going on here? In biology class, students are taught about genetic variants where there's sometimes something called a heterozygous advantage. So homozygous means two of the same copies, the same gene from your mother and father. Heterozygote means you got something different from your mom and your dad. And sometimes that can be a so-called advantage. All right, and the classic example is sickle cell anemia. If you have both of the sickle cell anemia genes, so a copy from your mom and your dad, the person will have sickle cell anemia, and that's a bad disease. However, if a person has one copy of a normal gene and one copy of the sickle cell gene, that's called the sickle cell trait. So that's heterozygous, when the copies of the gene type are different from the mother and father. And that is protective against malaria. The person's less likely to get sick or as sick from malaria. You'll also hear about people being hypomanic. Sometimes so-called hypomania on a relatively chronic basis can be an advantage. A person has more energy. But to have full mania, like what can be associated with bipolar disorder, that's bad. The person's crazy. So anyways, what I was thinking when I saw this duplicated gallbladder is maybe we're witnessing so-called evolution in real time. And perhaps this is related to the modern diet. And perhaps, here's a normal gallbladder. There's just one gallbladder. The liver makes bile. The bile is released into the biliary system. This is the common hepatic duct. Cystic duct here goes into the gallbladder and it's stored there. Then when they eat a fatty meal, the gallbladder contracts and it pushes the bile down through the common bile duct down into the intestinal tract. And that helps to emulsify the fats to facilitate digestion so the pancreatic enzymes can get them. Okay, so the point is that's normal, whereas this is what I saw recently in a patient, and I thought this might be some type of, evolution in real time, whereby maybe one gallbladder is storing emulsifiers that work better with polyunsaturated fatty acids and like all the fried food and cooking oils, and maybe this one is for saturated fat. So anyways, thought that was funny.